The project follows the journey of Amin, a waste scavenger in metropolitan Jakarta, Indonesia, relying on sorting of waste in the landfills. In the beginning, he moved to Jakarta in hopes of having a better future. But the overpopulation of the city, and the skills he possesses have forced him to work in the landfills. With barely any protection against the elements of the landfill, he has developed multiple respiratory problems. With a daily wage of $5, he cannot afford to stop working nor even get proper treatments. The pollution from the waste has encroached into the nearby fields and farms. Many of the farmers have no choice but to turn into the scavenger life. As the government starts tightening on their borders on the importation of waste, their newfound livelihood is being threatened. Concurrently, the global demand for waste recycling continues to rise. With the increased demand, the villages form a coalition with nearby recycling plants and NGOs to form waste banks, allowing the recycling industry to continue. Concurrently, the constant rising sea level has forced the government to move the sinking capital to the neighboring island of Borneo, leaving behind the most marginalized poor in the sinking capital. With millions of its residents in danger, the government has no choice but to accept the new proposal of building a new micro-city stemming from the old capital.
This micro-city is based on 4 ecosystems. Firstly, recycling as the main building block for the community, as well as its primary source of energy. Next, algae is used for the production of clean water and air. For food sustainability, aquaculture and hydroponics are used. Finally, the housing ecosystem, making it a livable society. Using the distinctive layers of the existing city, a site analysis was performed to determine the suitability of different areas within the site. From this, the areas where the ecosystems are to be anchored onto were determined. These main anchor points are then used to generate a mesh that allows for a flexible yet controlled growth of each ecosystem. The various elements are entirely connected, forming a closed-loop ecosystem, where the recycled waste is then used for building the main infrastructure system. The algae ecosystem acts as a mediating element as it cleans and processes the wastewater for daily use. The main recycling processes are represented in pink, forming the base of the ecosystem, leading to the yellow zones where the upcycling happens. The green then represents the microalgae infrastructure for the production of clean water and biofuel. The housing grid is located between each of these algae spines, where the living spaces and aquaculture intertwine. 2030. The capital has moved, leaving behind the poorest of the poor. In the first phase, the recycling facilities will be set up together with the microalgae infrastructure. This makes up the base groundwork for the community to grow. Concurrently, the city will start to clear up the areas closest to the coastlines as the threat of rising sea levels encroaches. The waste material that has been generated within the area will be brought closer inland into 3 main waste consolidation zones. 2050. In the second phase, sea levels will begin creeping further inland, and the waste consolidation zones will start accumulating. New ecosystems will then start to grow from the waste consolidation zones. At the same time, these areas within the vicinity will be torn down, generating resources for more communities to form. 2080. As more communities start to join, clusters will start to grow from the waste consolidation sites within this area. As the farming communities rejoin the housing clusters, aquaculture will thrive yet again. Moreover, each of the communities will be further connected as the main algae infrastructure housing the commons continue growing. This algae infrastructure forms the main highways of connection within the site, steadily forming an interconnected network of different systems as the community start reclaiming the area that has now been lost to the sea. Waste sorting. The heart of this project is the sorting process, where the waste is sorted into its base components through the use of sophisticated processes. These processes are strategically linked to allow for an effective sorting of materials. A combination of sorting and recycling processes allow for the waste to be sorted and recycled into the main components, ready to be used as raw materials. This cascading infrastructure allows for the waste to be sorted efficiently, as they are directly channeled to the respective recycling systems, funneling the waste downstream. Upcycling. The upcycling consists of three main upcycling plants: the steel upcycling plant, the glass upcycling plant, and the composite recycling plant. The materials made are then transported to the temporary assemblage modules where base infrastructures are built. Each building block is made up of three predominant materials: the base structure made of concrete composite, recycled steel, and glass. Algae infrastructure. The algae infrastructure acts as a bridge between the productive systems and the living quarters. Different algae cultivation systems are deployed to cater to the specific needs within the ecosystem. The algae infrastructure consists of three fundamental systems. 1. The algae runway ponds. 2. The algae closed-loop system. 3. Algae processing system. The runway ponds serve as a base cultivation where seawater is desalinated to produce clean water for use within the productive system. The closed-loop algae system is designed based on the volumetric need of each living cluster, where all the loops are connected back into the main algae system. Each loop caters to one living cluster where grey water collected will be processed by the microalgae before it is reintroduced. All the different systems are linked together through the processing plants. Each processing plant houses a research center where algae technology is researched and developed. One example is the upcycling of the byproducts in the cosmetic industry. Commons. The Commons are made up of 5 programs: the Marketplace, forming the base of the Commons; the Learning Labs, where residents can learn more about different recycling processes and the algae infrastructure; childcares, clinics, and entertainment centers make up the remaining 3 programs. Within the Marketplace at the base, the Commons are agglomerated, catering to the growing need of the community. The Commons also serve as a bridge between the productive spine and the housing modules. Let's take a closer look into the Marketplace. Housing. There are 8 different housing configurations, catering to different types of family. A range of different housing typology, from studio apartment for transient workers to larger apartments catering towards bigger families. The housing grows from the commons as more people move into the safe haven of this new microcity. Within the enclave of the housing infrastructure,
the algae infrastructure also acts as a second skin, controlling the amount of light that is being let into the house.
Aquaculture is practiced. Through the analysis of diverse aquaculture systems, seaweeds and mussel cultivation were chosen due to their suitability in shallow seawater. The aquaculture modules allow for the community to cultivate their own food, allowing them to be self-sustainable. Let's take a look into how people are living within the community.